Welcome back, grade 12s. Let's continue with our review of paper 1. So now we're dealing with a nice topic, money, right? But then this is financial maths, not money in that sense, where you just get it for free, right? But now let's look at the concepts that are being touched on here and how we would go about them. Okay, so looking at 6.1, Patrick deposited an amount of 18,500 into an account earning R% interest per annum compounded monthly. And now they're saying that after 6 months, his balance was 19,319.48 cents. Okay. Okay. So now the first question here says that we must calculate the value of R, which is the percentage. Okay. So in this case, we should know that this money was growing in that account, was growing at a compounded rate, isn't it? So remember that you can grow money in two ways. You can look at it from compounded or using the straight line method. Okay. So now in this case, we were told that it's compounded monthly. So we're going to use the compounded formula. Okay, let's go down and answer that question. Okay. Yeah. So 6.1.1. So A is equals to P, 1 plus I to the power n like that, right? So this is because we are growing money and it's compounded, okay? So now in this case, we were told that Patrick ended up with 19,300 and I believe it was 319.48, whereas he deposited how much? 18,500, 1 plus, and now we're looking at the rate at which his money is going to grow. That's the value that we're looking for in this case. So in this case, we can say R over, remember that R is the value, is the percentage that we're looking for, right? So usually we would convert this into a decimal by dividing by 100. So how would we represent the interest there? We'd say R divided by 100 like that. So now in this case, it's also compounded monthly. So it means we should take into account the division by 12. So this means that we are going to end up with R over 1,200 like that. Okay, so let's have our 1,200 like that. Now, for how many months? In most cases, we would change this into n times m, right? Because now we are having some compounding rate here. Okay, so in this case, it's 0.5 years, which is half a year, isn't it? 6 months multiplied by 12, so which would be just 6 there. But I don't want you to go through this route. The number of months that you would have been given up here, in this case, 6, 7, 8, 12, you don't have to convert or multiply by anything. Just place down the number of months as they are. If maybe we were given that it is for 36 months, then we would just write 36. Okay, no need to crack your head and trying to move from months, years, and so on. If you're given in terms of months, place it as months. If we're given in terms of years, then we definitely have to convert those years into months by saying the number of years multiplied by the compounding here. So which in this case is 12. So here I'm just going to place 6. And now our entire job is to solve for R like that. So I'm going to divide both sides by 18,500. So I have 19,319.48 divided by 18,500 like that. Okay, so this is equal to 1 plus R over 1,200 to the power 6. So I want to remove the power 6 right there, the exponent 6. So what will I do? On both sides, I'll take the 6th root. The 6th root. So like that. I know that this side, this will remove that, and I will just be left with what is inside the bracket there, which is just 1 plus R over 1,200 like that. So this side was still left with our 6,19319,48 all over 18,500 like that. So now I'm looking for R, remember? So I could take this one to the other side, and we are going to have root of 6, 19319,48 all over 18,500 minus 1 like that. And now I'm left with R over 1,200 like that. Okay, so now I want to remove this 1,200. So I'll multiply by 1,200 on both sides. Okay, so now I want you to be careful with this one. When you multiply, remember that on the left we have two terms, isn't it? We have two terms. So I'm going to have my 1,200 on the outside like that, which is going to multiply the entire thing that was on the left, which is, let me just move down, which is going to be 6 root of 19319,48 all over 18,500, and we have a negative 1 right there. And we're left with the value of R like that. Excellent. So now what is going to be our value of R? Then you'll see that you are going to get 8.70 like that, and that would be your value of R. Hopefully everyone is with me on this one like that. Okay, so let us go on. One thing that I want to say here, I did not change these into decimals because I don't want to have or introduce rounding off errors. So I know that when this divided by that, surely it will give me a long decimal number. And even when I take the 6th root of that number, it might give me another decimal. So for avoiding rounding off errors, I just kept it like that. And when it came to this part, I punched it into the calculator, just like this, okay? And I ended up with that value of R right there, okay? So let us go on to 6.1.2. Let's find out what they are they looking for from us. So now they say, calculate the effective interest rate, okay? So now we know that with I effective, this is equals to 1 plus I norm. Usually it's the one that you are given on the question paper. And how would you spot it? It would have some compounding rate there. Compounded per month, compounded monthly, compounded quarterly, compounded so on. If it has that, you know that you're dealing with the nominal in this case, divided by m like that to the power m minus 1. So now this is the value that we found, right? This is the value that we found. So that's the value we are going to replace in here. So we're going to have I effective is equals to 1 plus, now divide that value by 100. What are we going to get? Or you can place it with 100 like that, as you can place it with as 8.70 divided by 100. And you know that since m is going to be 12, it would be the multiplication of 12 like that, okay? This will still yield the same value, okay? Hopefully people understand that. So I'm going to place it in as a decimal after dividing by 100. So this would be 0.087 over 12 to the power 12 minus 1 like that, okay? And here we're going to find a number which is going to be 0.09055 some values that. So what I would like to do is I want to keep these values. Then for my final answer, I will multiply the decimal up here. I'll multiply the decimal up here, right, by 100 to change it into a percentage. Then and only then will I cap off my value. Will I round it up, okay? Or round off, rather. So in this case, when I multiply by 100, the final value becomes 9,06, and you know that this turns into a percentage after multiplying by 100 like that. Okay. Hopefully that makes sense. Okay. So that would be the effective right there. Let us go on. Let's see what's the next question. Okay, we have 6.2 here. In 6.2, they're saying, could I bought a laptop for 10,000 rands on 31 January 2019? He will replace it with a new one in 5 years' time on 31 January 2024. Okay. So we're given that piece of information. And surely from in between these two, you see it's 5 years. We could convert this into months. So meaning that we would say 5 times 12, that gives us that value of 60. So it would depend with the question. Should we, shouldn't we? But we'll find out in time, okay? So now what do we have here? We have 6.21. They're saying that the value of the laptop depreciates annually, so per year, at a rate of 20% per annum, according to the straight line method, okay? Now, after how many years will the laptop have a value of 0 rands? Okay, so we know that the initial price is what? 10,000. And now this laptop is going to depreciate at that rate, isn't it? According to the straight line method. And it's going to end up with 0 rands. So 0 rands there would be the book value, or the scrap value, rather. If he would sell it after those many years, we would find out that he should just give it for free, isn't it? Because there's no profit to be made from it. Okay. So let us calculate that value there. Right. Okay. So we have 6.2. Under that, we have 6.2.1. Right. So we have A is equals to P into 1 minus I multiplied by N. My good people, this is the straight line method, right? So now they asked us, after how many years will it have? 0 rands. When it started out as 10,000, so 1 minus, and it depreciates at 20%, isn't it? So that is 0,2, and we're looking for the value of N like that. So you can divide both sides by 10,000, and you'll see that you are left with 0, 1 minus 0.2N. Take 0.2N on the other side, then it becomes positive. You're left with 1 this side, and 0.2 divides that value there, and you get that N is 5. Okay, so they did not say calculate N. They said after how many years will it have. So therefore, after 5 years. Okay, so when he plans on replacing his current laptop, right, that he bought in 2019, after 5 years, 2024, the laptop is worth 0 rands. So he would rather give it to his little brother if he has, or sister, or whoever. He should just give that laptop out for free. Okay. Or if he wants to make some money from that laptop, he would sell it before 5 years. Okay. So let's go on to 2.2 then. In 2.2, they're saying, Kuda will buy a laptop that costs 20K. In order to cover the cost price, he made his first monthly deposit into a savings account on 28 February, okay? He will make his 60th monthly deposit on 31 January 2024. The savings account pays an interest at 8.7% per annum compounded monthly. Calculate Kuda's monthly deposit into this account. So now, if this was a regular, savings account, we know that he would have just made a deposit once off and let it rest in the savings account, isn't it? So now here we notice that there are some monthly deposits being made. There are some regular payments. That's the word I wanted. There are some regular payments that are made here. So this turns this into an annuity. And you know that you and I have two annuities that we're studying, isn't it? We have the present value and we have the future value. So now I want you to look at this keyword here. Coulda will, right? Will. It means that this is in the future. He hasn't bought it yet, but he plans on buying it. Okay? And he keeps on making these payments into this savings account so that he can accumulate 20K at the end. So that at the end of that period, Huda can then afford this 20K laptop. So this is going to be a future value annuity, my good people. Okay. So now here we might be confused. So what's happening on the 28th of February, right? This is 1 month after he has opened, right? This is 1 month after probably he has opened this savings account. So this is just a normal case where you start making your deposits month end. Okay. So we are happy about this information, and we do not need to calculate the number of payments that he will make. We are given that piece of information here, right? And remember that he will replace this laptop in 5 years' time. So if you said 5 multiplied by 12, you definitely get that 60. And this is the 60 we're given here. So we have all the details, basically, to solve this question. So now let us go on down there and solve it. So we said that this is a future value question. So FV is equals to X, which are the regular payments. And we have 1 plus I to the power N minus 1 close all over your value of I like that, isn't it? So now the future value, how much he wants to accumulate is 20 grands. So we have our 10 grands right there. We are solving for this X, the monthly payments. So that's the value that we don't have. In here, we have 1 plus. Now remember that compounded monthly. So we need to treat that accordingly. So this is going to be 0.087. Remember that it was 8.7% per annum compounded monthly. This savings account pays him an interest of that. And this will be over 12 right there. And up here, we just place in our 60. So, and have minus 1 right there. All divided by I, which is just the same thing, 0.87 over 12. Okay. Now, my good people, I wouldn't like you to solve it all things this side, okay? What I would want you to do is manipulate this quickly to make X subject of the equation. So how are we going to do that? First of all, we have to remove the denominator right here by multiplying it by both sides. So we're going to have 20 grands multiplied by 0.087 over 12, okay? And now we have X into this entire bracket of 1 plus 0.087 over 1, 2 to the power 60 minus 1 like that. And now we're going to divide both sides by this entire bracket without having to punch it into the calculator or solve it, isn't it? So let's divide by both sides, and you'll see that what you're going to get is 20 grands 87 over 1, 2 all over that bracket there, which is 1 plus 0.087 over 12 to the power 60 minus 1 close. And this will give us the value of X. So now this is what I want you guys to punch into the calculator, all right? So please be very sober and vigilant when you're punching this in, because we do not want to find or to get wrong answers. So this will be in rands then, and you should find 267.26 cents. So these will be the payments that he would make every month in order to cover up the laptop that will cost him 25 grand at the end of 5 years. Excellent. Nice and easy. Okay. So let us go on to the next question here. We're done with 6.2. Let's go on to 6.3. It is said that Tino wins a jackpot of 1.6 million. That must be nice. He invests all of his winnings into a fund that earns an interest of 11.2% per annum compounded monthly. He withdraws 20 grand from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20 grand will Tino be able to make from this fund? My good people, I do not want you to be confused when it comes to this. Tino wins a jackpot. When does Tino get the money? Tino gets this money now. Tino gets this money now, isn't it? So now we want to find out. He's going to invest these winnings into a savings account. But then he makes monthly withdrawals, isn't it? So if you have regular payments or regular withdrawals, then it becomes an annuity. Now the question is, which type of annuity? This would be a present value annuity because Tino has the money now. Okay. And now here they're saying that his first withdrawal is exactly 1 month after his initial investment. This is your normal case. Remember that usually when we make payments of a loan, think of the loan in this case, when you make a payment of a loan, 1 month after taking the loan, that's when you usually make your first payment. All right. So now this is a reverse of that. Instead of thinking in terms of loan, we are thinking of in terms of the winnings, and we're leaving off those winnings. Okay. But then we're going to treat it as we would with a loan. Because I know that most of the problems that we face or the questions that we were asked when it's concerning the present value were asked about the loan. But now, think of a loan, but then the loan is like it's to your benefit. Yeah, we could put it like that. Okay, so now let us solve that question right there. We have 6.3 here. So we said that this is a present value annuity. So we have X, in this case would be the monthly withdrawals, and we have 1 minus, now 1 plus I to the power negative n like that, all over I like this. Okay. So hopefully that part is clear to everyone. Okay. So now I want you to remember a few things. The value of PV is how much we have currently, isn't it? And that is 1,600,000. And how much are we withdrawing per month? Or how much is Tino withdrawing per month? That it would be 20,000. Okay. And we're given the information that our value of I is 0.112. So this is when I've divided by 100 like that. Okay. So now let us substitute and solve for n in this case, because that's what we're looking for, right? This is what we're looking for. The number of withdrawals that Tino will be able to make. In most cases, when you are dealing with a loan, this would be the number of payments you would have to make to amortize that loan. Okay, so now let's substitute 160,000 equals to 20 grands into 1 minus, here I have 1 plus 0.112 over 12 minus n. all over 0.112 over 12, like that. Okay. So now, again, I would just manipulate this as we did with the previous one, up until we cannot manipulate it any easier. Okay. So I would say 1 multiplied by the denominator, which is 0.112 over 12. Now I'll divide by 20 grams. So divide by 20,000, like that. And this side, we're going to have 1 minus. Now, in this bracket, we can simplify this. 1 plus, we can just find out what this value will be. In most cases, when you simplify this guy here, you are going to get a fraction. So we're happy to work with fractions. They are more compact, isn't it? So this would be 757 over 750 to the power negative n, like that. And now what you can do is take this entire thing, negative of 757 over 750 to the power negative n. I could take it that side so that it becomes positive. And I could take this entire sum this side, or this entire expression on the other side, right? So now I'm going to have, now this is positive 757 over 750 to the power negative n up there. And what am I going to receive this side? 1 minus this entire thing here. 1,600,000 multiplied by 0.112 over 12 all over 20 grams. Okay, so now we see that we cannot simplify this guy any longer. So what are we going to do? We are definitely going to punch this part into the calculator, right? Punch it to the calculator, and you should receive a nice fraction there. I like it when we work with fractions. They are less complicated. So we're going to receive a 19 over 75, like that. And on this side, we still have our 757 over 750 to the power negative n. So now, anytime we're looking for the value of n in this case, we know we're going to use our trusted logarithm. So negative n is equals to log of the base, is our guy there, 757 over 750, and we're taking 19 over 75 as the argument. Now you notice that this value is going to be negative. So this value must be negative as well. So the easiest thing to do is multiply both sides, or yes, multiply both sides by negative. So this will become positive this side, and you can punch it in into the calculator looking like that. 7 over 750, 19 over 75, like that. Okay, so now what we're going to receive is a positive number. So n is equal to, and we're going to have 147, 7978, and other values going on like that, right? So now, how are we going to answer this question? They said that they want the number of times 20,000 can be withdrawn from the bank, isn't it? So we are looking for 20Ks, not when it will be 0, but the maximum number of 20Ks they can withdraw. So in this case, we're going to have how many? 147. Therefore, 147 withdrawals. Why are we not saying 148? Because this 0.7978 represents, or is going to represent, the values that are going to be less, right? So it means that the number here is going to go along with some amount R, which is going to be less than 20,000. Hopefully this is clear. Hopefully this is clear. So this 147 would be the number of withdrawals we can make of 20,000, right? Then after making this number here, we are going to be left with this amount. But this amount here, or this n, this value of n, is going to correlate with some value of r, which is going to be less than 20,000. Okay, now I want to take you to the balance or the last payment. Usually last payment, right, is less than your monthly payments. Is usually less than your monthly payment, or is in most cases, definitely is less than your monthly payments. So it means that after withdrawing 147, what we are going to be left with in the bank account is some amount X, which is going to be less than 20K. So that's why we're not going to round it up, but you're just going to take 147 in like that. 147 withdrawals of 20K can be made. Okay, that was it from money, and I will see you on the next one. Cheers.